Okay, so like that you have to just go through. When you go through the PDF copy itself, you can understand that thing, because certain things alone, in certain pages alone, I would have done that steps at the back. Okay, so how the steps comes, I would have noted. But once if we are knowing A, B value means C, D value, like minus sign alone, it has changed, right? Yes or no? So once if you know how to substitute and get the value of A, B in the general solution, C, D, automatically you can write the reverse values, right? One or two values alone it is changing. So like that you can do it. So every steps you cannot write for 13 marks. So only the equation is expected. Yes. So it is a general solution means as per the question asked 13 mark, 15 mark, based on the question you have to answer the one. If it is 8 mark means subten times the derivation will be big derivation, but I have asked certain steps alone. So in that certain steps you can leave. See, quarter wave from this, if you see in this university question in the third unit, the quarter wave transformer has been asked as a 16 mark question also. It is asked as an 8 mark question also. So 16 mark means I will be giving the derivation for 16 mark means to the certain part of the question they have asked. Okay, so I'm always giving the lines also, right? So you can just, if you are without reading the lines, if you are learning means, then you will not know where to stop it, right? So you should know where to stop the things. If 8 mark means up to that content, if you write it is enough. If you are writing full means you can write no problem, but thing is you will not have time. So you have to know how to condense and write your answer. So in this topic also, as we are doing, so here if you see the beginning topic alone, we will be solving with the problems and single step, double step and all. If you see in the syllabus itself, single step and double step first they have given, and then in the last of the syllabus if you see, they have given single step and double step using Smith chart. Okay, so that way since they have mentioned, we can use the stop, the single stop and double stop, plus the other thing, application using Smith chart also they have asked. So the ordinary calculation of characteristic impedance, pole calculating everything, we have to use the chart and we have to do the calculations. We are able to follow. So this unit if you see, quarter wave length means lambda by 4, we will be substituting in the input impedance. So everything, the input impedance already have derived in the unit 2. So from the first unit, the continuation is for the second unit. From the second unit, the continuation is third unit. So in the third unit, if you just remember the topics I will give first, the syllabus, note down first the syllabus, then we will go to the topic. Okay, what to study for that introduction part I will give. Unit 3, put a heading, Unit 3. Unit 3. Impedance matching in high frequency line. Impedance matching. This is in high frequency line. High frequency line. So this is the third unit main heading. Impedance. See, last time read high frequency in transmission lines we have studied in the second unit. So third unit deals with impedance matching in high frequency line. Okay, so that means we will be taking the impedance matching formula and then we will be applying the other things. Yeah, that's why it is saying impedance matching in high transmission line. So what formula of the input impedance you have learned in the first unit and you have learned in the second unit. So which formula will be taking? Second unit formula, because impedance matching in high frequency line. So the impedance formula of the second unit will be used throughout this unit. Okay, first topic note down, impedance matching. Impedance matching. Under that put a hyphen like this and write quarter wave transformer. Quarter wave transformer. Quarter wave transformer. Comma half-wave line. So half-wave line, if you see, you have to write the impedance matching form. That means input impedance formula. In the place of lambda, we have to substitute as lambda by 2. And if it is quarter, means lambda by 4. Like that, we have to substitute the values in the input impedance formula alone. And we have to derive. So see, this question is in one of the university questions they have asked, discuss with impedance matching. They did mention whether it is a quarter wave or it is an half wave or 1/8 line. So these three topics belongs to the impedance matching. So if simply they say discuss with impedance matching means you have to write generally about the quarter wave line, 1 wave line, half wave line. So you have to write impedance matching these three topics, and then you have to write the formulas like that, how to condense and write for 8-mark question. Are you able to follow? If I say discuss impedance matching without mentioning any topic means generally you have to write about this topic. Now another thing, this university question, second one, quarter wave transformer, one of the university questions, they have asked to derive the expression for quarter wave. So that means only the derivation part you have to write. And another question they have asked, discuss the quarter wave transformer and its application. So application part carries the remaining mark. Application is 2 applications they have done. What is the application of quarter wave? That means it can be asked before, it was asked 15 mark. Now for the part C question also they can ask, right? So it can be 15-mark question. And then 1/8 wave line is just the formula derivation, and the half-wave line is also derivation. So it can be asked 4 to 6 mark. 1/8 line and the half-wave line is very simple. 1/8 line is 6 mark, 8 marks they can ask. So this is the way, this is the first topic. So impedance matching is not yet. Under the impedance matching, we are having this topics, 3 topics. Are you able to follow? The next topic you know down, impedance matching by stubs. Impedance matching by stubs. Impedance matching by stubs. Under that you know single and double stub matching. Impedance matching by stub is a general topic heading. Okay, under that subheading, single and double stub matching. Single and double stub matching. So both are university questions only, theory questions without Smith chart means derive the single stub matching and derive the double stub matching. So double stub matching is very small thing only. So 8-mark question like that only they have asked. Explain the double stub matching and its expressions. Like that they have asked for the university question with 8 marks. But single stub matching is derivation, very big derivation. Okay, so that also if you see, it has been asked as a 16-mark question, double stub. Not double stub, single stub is 16 marks, double stub is 8 marks question only. Okay, so this is the next theory part of this unit. So first part, 3 topics under impedance matching. Second part is what? Impedance matching using stubs. So under that, the single and double stub matching. Next one I know down. Next comes the Smith chart. Smith chart. Next comes the Smith chart. So under the Smith chart topic, the general description. Sometimes they are asking explain the Smith chart, not diagram as a theory part. So Smith chart, you know down, and under that the subheading is applications of Smith chart. Applications of Smith chart. Then solution of problems. Solution of problems using Smith chart. Solution of problems using Smith chart. Then next subheading single and double stub matching using Smith chart. Okay, so the theory part question is quarter wave, 1/8 line, half-wave line, and single stub and double stub matching. Then application of Smith chart and Smith chart general description. Brief description of the Smith Smith chart is also a theory question. So all others in this unit is small problems under the first one wavelength, quarter wavelength. This we can see the problem, and then the remaining problem solutions are not using remaining problem using Smith chart and single and double step matching. Also you have to do the problem using Smith chart. Okay, so that means half of the unit is Smith chart, half of the unit is this. So some people they take only questions from the upper, other people take one question from that, another question from the Smith chart. Okay, because now 15th question can be from any unit. So some people can ask from the application part, they can ask us from the Smith chart. So you cannot say from this unit only 2 questions will come, right? Any unit 4 questions or 3 questions can come. So you have to be prepared for that. So Smith chart analysis, we are learning the chart itself. Chart means the graph, new one, right? So until you practice in this class, listen, that means you have to know how to plot a graph. All the values have to be calculated not using the formula, using the Smith chart. Okay, so you have to observe it without bringing the graph sheet. If you are coming simply without compass, scale, pencil, everything, individually everything you purchase it in scale, pencil, rubber and Smith chart. Then only you can learn this chart. And during that time, you should not take leave, because first problem when you are on leave, next problem you cannot solve. Right? First problem alone, you have to teach bench by bench. So after that, somewhat if I explain from here, you can draw the thing. First time, small problem is started, and then this. Okay. So this is the concept behind this unit 3. So unit 3, if you see, the derivations are not tough except the single step. Single step alone, the derivation means from one equation to the other, only it is written. So the derivation is not, they cannot say this stuff. Like from one thing to the other when you are moving, some last point, length of the step using the distance S1, S2, when you are doing the calculation, it's taking a lot of time. So at least we need 2 classes to complete over the theory part of the Smith chart itself. All others we can complete it quickly. Quarter wave or transformer also, since we have to deal along with the application of the quarter wave transformer, it will take time. All others, if you see, the concept is substituting the lambda value in the input impedance formula. That's why impedance matching in high frequency lines. So now note the first heading, impedance matching. Impedance matching and impedance transformation. Under the impedance transformation only this 3 technique comes. Impedance matching and impedance transformation. Impedance matching and impedance transformation. The transmission lines of different wavelengths, can be used as impedance matching, can be used as impedance matching and impedance transformation. The transmission lines of different wavelengths can be used as impedance matching and impedance transformation. Okay, so the 3 techniques only. The first technique is what? Under the impedance matching, quarter wavelength is a frequency. So first we will learn the 1/8 line and half wavelength, and then we will learn the quarter wavelength. So 1/8 line. 1/8 line. Lambda value alone will change. No doubt. Let lambda be the wavelength. Let lambda be the wavelength of the transmitted frequency. Let lambda be the wavelength of the transmitted frequency f. Consider a transmission line of length. What will be the value for 1/8 line? Lambda value. Yes, 1/8 line. Lambda by 8. Okay, note down. Consider a transmission line of length lambda by 8. If it is half means lambda by 2. Quarter means lambda by 4. Okay. Consider a transmission line of length lambda by 8 and draw this diagram alone. Just the first diagram you already drawn, right? Same diagram we are again drawing. ER. See, the same diagram only I drew it in the second unit, I drew it in the first unit also. Same is that R. So just the same, see, diagram and all we are not learning as a new one. The first diagram which we drew in the general solution of the transmission line, the same diagram only we are drawing in the second unit also, third unit also. So here's the input voltage, input current, sending end current, receiving end current, load impedance and receiving end voltage. So this is the distance S is equal to lambda by 8. S is equal to lambda by 8. Next you know now the generalized expression. Vasan, that's lot of space, right? Move at the end and sit. Huh? What is the generalized expression for the input impedance for the high frequency line? You see the input impedance, second unit. I am saying the generalized expression, hold on. The generalized expression for the input impedance. The generalized expression for the input impedance is given by Zn is equal to, in second unit, same thing, I am just writing R naught Zr plus J R naught tan beta S by R naught plus J Zr tan beta S. Right? This is the generalized expression for the input impedance, right? From the second unit for high frequency line. Generalized expression. So what is the beta value? Beta value is what? Beta is equal to what? Beta is equal to 2 pi by lambda. Substitute first beta value, then only you can substitute lambda is lambda by 8, right? So substitute in this equation 1. Beta is equal to 2 pi by lambda. Substitute. So Z is just I am substituting for the beta value as 2 pi by lambda. So Z plus J R naught 2 pi by lambda into S. S first we will not write. First we will write as S itself, and then we will write in the next step the value of lambda. R naught plus J Z tan 2 pi tan eighth wavelength. For a line of eighth wavelength, S is equal to lambda by 8. Yes. For a line, S is equal to lambda by 8. So substitute S is equal to lambda by 8. Substitute Zn is equal to what do you get? R naught Zr plus J R naught tan 2 pi by lambda into lambda by 8 by R naught J Zr tan 2 pi by lambda Substitute and simplify the equation.